For the query server is a very similar approach to the transaction or message server. We'll have to add here inside the keeper directory a new file that we're going to call query server, where we are going to include all our queries. This is going to be our package keeper, and similarly we'll define a query server type, query server, that's going to have a keeper, our keeper for our module, and we are going to have this to comply with the query server interface that we define in our proto query server. This, as you can see, has this getGame and getParams that we define in our proto file, and we'll have to comply with this interface. First, let's create a function to create a new instance of the query server, new query server implementation, and we will get the keeper as input parameter, and we'll return a query server interface. That's going to return our query server with our keeper here. Then we'll have to define for this type function query server, the two functions getGame and getParams, get the corresponding imports, and this getParams function QS query server has this getParams, and this is in the package types, and it looks good. The getParams, we can get it from our example module repo. You will see that this is quite standard, and most of the modules have this implemented the same way. So we can get this getParams here, this function. The logic is the same for our case. We're going to get our context. This is going to be a message. The error not found, we can use that. This is types. This is types again, and types again. And this should be query getParams response in our case. Well, in this case we can return nil here, and in this case params. Yeah, for some reason we don't have param name, but well, just a naming, no worries. There we get the params. And for the getGame, we'll have to add our logic. It's also straightforward. We're going to get the game by ID, so we're going to look into our keeper for this game, games, get the context, and it's going to be this request. Let's call it request, but actually we're not using it, so we can remove it, the naming here. Oh, I need to have something. So the request is going to be request index. It's the ID of the game. If we don't get an error, we will return the corresponding response. Types game, it's going to be our game. and no error. Otherwise, if the error is collections not found, we're going to return a nil instead of an error. We're just going to say an empty game. This game does not exist. We're not going to throw an error, but we're going to return an empty struct. Let's put the name here, context for this variable. And if it is another type of error, we'll return the error. Return nil status error and codes internal, and the message is going to be the error. You see, it's a similar approach to what they have here in the example. You manage the not found and return what would be an empty response. And because we are using the get params here, we can also add the update params logic. We can pick it up also from this message server. It's quite standard as well. We are going to use the same logic. That is just checking for the authority, if it is the correct one, the correct address, and let's just really quick do this. It's checking for authority, then it's running the validate function for the params, and if everything's okay, it updates the params. Straightforward. Let's import these dependencies that are native in Go, so no problem with that. Now that we have our query server functions defined, we have to wire it up in our module. We'll have to include them here to register our query server. Now that we have defined this query server implementation, we can safely uncomment this and register it properly. And we can also register the gRPC gateway that would be allowing it to be accessible via HTTP. So let's uncomment this and get the context import. So here I got the context import. And now we have our query client, but still we have to wire it up in our auto CLI. Let's see the example. So we have auto CLI. And let's look for this. We're going to get just this first command and then modify with what we need. This should close here, and then we have the transaction. This is RPSv1 query service description service name, and we're going to have the get game method query game, and you will need to provide the game index, get the current game, with the provided game index, and we need game index here. Get game, that is good enough. And also we have the get params that we can add it as well. So we have it there already, this other command, but in our case it's going to be a get params, use params, get current value params. So let's try it out now. Let's install again our binary, make install. And now let's start again the chain. We have some issues. Can't find game index, get game request. Try, well, I think it is the problem here. Get game request, it's just called index. It should be called index instead of game index. Now it should work. Let's install again to get the latest changes into our binary. And let's try starting. Now it's working. Let's see if we have now the RPS. Here we have this module for subcommands for that specific module. Help. We should get the two subcommands, gain, get the gain, and the params. Let's run the query for game with game ID 1. And as you can see, now we can query our game. Right now this output is type text, but if you want, you can have an output with the flag output. You can have JSON output, and you get it there clearer what the status of this game is. Now you may be thinking that this is not a very good design for a rock paper and scissors game, because the player that now has to play already knows what's the move of the player A in this case, so it's going to win this round at least. But no worries, we will implement a fix for this in the next module, where we are going to upgrade our chain to comply with the commit and reveal protocol. So the player will submit a commitment, and then it will be revealed the move once both players submitted their move. But for now, it's good enough to just wire the app and test this.